12.4 is kind of the trickiest one in Chapter 12. It's the surface area of pyramids and cones. So these are a couple tough formulas. I always have to look them up just to make sure. I really should memorize them, but I have trouble with it. So remember with surface area, what you could do is you could just find each individual face and find all of those areas and then add them together. You know, we talked about that. Like if we had a rectangular, like a box shape, we could do the front and back, right and left, top and bottom, and add them all together. Same thing here. So you could do exactly the same thing. So if you were going to find like the area of the triangle on the side, so this triangle right here, you would need to know the height of it, which is right here. We call this the slant height, and we usually use an L for it. So L is equal to the slant height. So then the regular height of this pyramid goes down to the center, just like before. But that's not really used for the surface area necessarily, but we use it for the volume equation. Okay, so slant height is typically what we're using for the surface area because it's the height of the surface, right? Okay, so a pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles, and they go to a common vertex. So they go up to that single point. And a regular pyramid is exactly what you think it is. It's a pyramid where it has a regular polygon for its base, so like a regular hexagon or something, and then its height meets at the base of its center. So here's our example. So it says the Great Pyramid of Giza in Egypt is the only remaining members of the 7 wonders of the world, so the ancient 7 wonders of the world. So it's about 230 meters, 231 meters on each side along the base, and it's about 139 meters high. So it says, what is the surface area of the pyramid? So we're going to come up with each individual piece. So let's talk about the base first of all. So the base is a square. So how do I find the area of that square? Yeah, side squared, right? I'm going to take that 231 and I'm going to multiply by 231. So I'm going to call that big B, kind of keep it like how we talked about it before. So big B always means area of the base. So 231 times 231. So it's going to be 53,361. So that's just the base. And then we need the triangles that are on the side. Okay, so in order to find the area of the triangle that's on each side, right, we call this the lateral area, we need to find the slant height. So we don't have the slant height. So what we do is we draw this straight over to the side, and then we're finding that slant height along the edge. So it's kind of hard to draw sometimes. It might help to draw it like this way. I don't know if that makes more sense to you guys. Did you guys see what I'm doing? And that's L, and then this is a 90-degree angle back there. So if we had 231, how much is the part that I'm drawing in blue right here? Half of 231, right? So we divide it in half. Yeah, so we get 115.5. So if we want to find L, do you see that we just do the Pythagorean theorem? So we're going to say 115.5 squared added to 139 squared equals L squared. So when I take the square root, I get 180.724. And my calculator says 724, 2374, and so on. Okay, so last step. So how many of these triangular faces do we have? We have 4 of them, right? Because it was going around a square. If I had like a hexagon for the bottom, I would have 6 of them, right? So I'm going to have 4 of these triangles. So I'm going to have 4 of the areas 1/2 base times height. So let's look at the triangle. Its base is 231. Its height is our slant height. So our base is going to be 231, like little b, and our L is going to be 180.724. So that number is still in my calculator, so I'm going to multiply by 231, multiply by 0.5, and then multiply by 4. So those 4 triangles have an area of 83,494.598. So our last step is to add our area of the base to that lateral area. So I'm going to write this as LA for lateral area. So we're doing the area of the base plus our lateral area. So we get 53,361 added to that 83,494.598. Lots of numbers. All day, every day, lots of numbers. So that's our lateral area, and that's in meters, or our surface area, and that's in meters squared. Okay, so it's a lot. Okay, does that make sense? Do you guys get it? All right, so we're doing one piece at a time. So it says a regular pentagonal pyramid. So when I say pentagonal pyramid, what that means is the base is a pentagon. So you guys can draw a pentagon. You don't have to draw it like slanty, like it's 3 dimensions or anything. You're fine. And it has a side length of 18 inches. The apothem is around 12.4. So do you guys remember what the apothem is? So it's when I draw in this little triangle, it's the height of the triangle, those 5 triangles. So this apothem is 12.4. So I did some of the math for you. You don't have to do your SOHCAHTOA or anything. It's there. And a slant height of 24 inches. Okay, so coming up off this base, we have 5 triangles that are going to meet at a point. You all see that? So it's kind of hard to draw like 3-dimensionally sometimes when you have the base going on. But here's what's happening. Okay. I see the panic in some of your faces, like I don't want to draw this. Okay, so let's start with the area of the base. So our base is a pentagon, so it has area 1/2 perimeter times apothem. So we're going to do 1/2. We're going to have 18, not 18, 18 times 5, right? For our perimeter. And then our apothem is 12.4. So we get 558 as the area of our base. And then we have 5 triangles that make up our lateral area. Okay, so here's what's happening on our lateral area. We know that our base is going to be 18. And then I gave you the slant height. So the slant height was 24 inches. So we're just finding 5 of those triangles. So we're going to have 5 of the 1/2 base times height, so 18 times 24. So that's going to be a total of 1080. So our total surface area is going to be those 2 added together. So 558 added to 1080. So 1638. Did you guys all get it? Okay. So that's what we would do if we're doing one piece at a time. So we found the 5 triangles, we found the bottom. Okay, now there is a way to put this all together so you can do it a little bit faster. Okay, so there's a formula, and this is what I was telling you. I always forget this formula because I always just think of it as the pieces. To me, that's easier to think, okay, I have my right side, my left side, my front, my back. So the surface area of a regular pyramid is S equals, and I wrote it down so I wouldn't forget, the area of the base plus 1/2 perimeter times our slant height. So it says think about a regular hexagonal pyramid. So let's say we have a hexagon along the bottom. The area of each lateral face is going to be, it has to do with our, so here I'll draw my lateral face on the side. It has our side length, right, whatever our side length is, and then it has L, our slant height. So the area for each of those lateral faces is 1/2 times S times L. Right, do you guys see that? And the perimeter of the base is going to be 6 of those S's. So if we put it together and we're like, oh, well, what's the area of the base? What's 6 times the area of the lateral face? Then we have our area of our base plus 6, and then our lateral faces are 1/2 SL. So the 6S, what was 6S? The perimeter, right? So putting it together, we have our area of our base plus our perimeter times 1/2 times L. So I'm going to write 1/2 PL. Okay, so you can do it a little bit faster that way. And then our area of our base, if you wanted to write that in, that's where it's like 1/2 perimeter times apothem plus 1/2 P times L. So sometimes you'll see people pull out the 1/2 P, and they'll have 1/2 P out front, and then it's like apothem plus the slant height. So you could do that as well. Okay, so it says a regular pyramid has a hexagonal base with side length of 4 feet and slant height of 9 feet. So our surface area is going to be the area of the base plus 1/2 PL. So since it has a hexagon for its base, we know to find the area of a hexagon, we do 1/2 PA. So we're going to have 1/2. Our perimeter of our base is what? That's the perimeter. We have 6 sides. They're all 4. So 24. And then we need to know the apothem. So if you remember, if you have 4 as our side length, we create this like equilateral triangle here. So if I wanted the apothem, it's a 30, 60, 90 triangle. So we would have 2 and 2, so I'm going to have 2 there. So what's the apothem? What's A equal to? Nope, that'd be over here. Tricky. Yeah, 2 root 3 or square root of 12, as you're saying. Yeah, you gotta know that 30, 60, 90, right? We talked about that. All right, yeah, so he did the 16 minus 4, right? He did the Pythagorean theorem, which you can always do. But yeah, it's 2 root 3. So that's going to be our A value. And then we have plus 1/2 P, again 24, times L, which is 9. So we have 12 times 2, so I'm going to get 24 root 3 added to 12 times 8 plus 108. Oops. Oh, apparently there's a early childhood play date today. I need to take my kids to that. All right, so plus 108. There we go. Okay. Have you guys ever made a cone like when you were kids? Like that's what the shape looks like when you pull it apart. But, I'm not going to talk too much about that. All right, was that it? Did I not have any more? I think I have more problems tonight. Yeah. What's your question?
Where did the 2 go with the 2 root 3? Did this?
I canceled the 1/2 of the 2, I think. Yeah, so like that and that went away. I was sneaky. All right, I think I have a couple more. Okay, so you guys have a box next that says surface area of a cone. A right cone, a straight up cone. So if we have a cone shape, it's a really similar formula. But we don't necessarily talk about the perimeter, right? What's the perimeter of the base? What would we call that with a cone? Circumference, right? So its formula looks a little bit different. It's just surface area equals our area of our base plus pi RL. And our area of our base is pi r squared. So for a cone, it's pi r squared plus pi RL. And the reason that works the way it does is because if you took your original surface area formula, which is B plus 1/2 PL, and instead of P, you wrote the circumference, which is 2 pi r. Do you guys see how the 1/2 and then the 2 pi r, those 2's will go away, like 1/2 and 2 goes away. And then we have our L. So it's area of the base plus pi RL. Okay, so it's a very similar formula. So number 1 says, find the surface area of a right cone with a base diameter of 10 inches and a slant height of 8 inches. So we have this cone, and going across the center, our diameter is 10, and our slant height is 8. So you can really draw the slant height anywhere on the cone, right? So our surface area then would be our area of our base, which is pi r squared, added to our pi r L. So we're going to have pi times, what's our radius? 5, yeah, so 5 squared, plus pi times 5 times 8. So it looks like we have like 25 pi plus 40 pi. So we'd get a total of 65 pi. So on your homework, like on Math Excel, I think it asks for like surface area and volume. And I do that a lot like on tests and so on, so it might say that on your final as well. So it might say find the surface area and the volume. So what if I asked you for the volume? Do you remember that formula from Monday? There's only 2 formulas you have to know for volume. Except for the sphere, I guess. Yeah, it's 1/3 area of the base times the height, right? And it's the 1/3 because it goes up to a point. It's like a pyramid or a cone. So anything that doesn't have 2 bases will have that 1/3 area of the base times height. Do you guys remember the surface area of a sphere, though? Yes. You're gonna know these. 4/3 pi r cubed, right? There is a way to relate them, like I said this in the video, with calculus, which makes it easier to memorize. All right, so anyway, so I get v equals 1/3 area of the base times the height. So it'd be 1/3, our area of our base is pi r squared, and then our height is h. So you would just go through that process, and you'd say, oh, my r is 5, but then you'd have to find the height. So our height would be straight up and down to the middle. So you always look for those triangles. So we would have 5 on the bottom, and then we would find the height. So we would do a Pythagorean theorem, so we'd say, okay, I have h squared plus 5 squared is 25 equals 8 squared, which is 64. And so you'd subtract it out. What do we get when we subtract out? H squared equals 39, yeah. So we'd have the square root of 39 in there, which doesn't really reduce. So our answer would be the lovely 25 pi root 39 all over 3. That would be like the exact answer. Does that make sense? So in that case, I would probably find a decimal version. All right, and then you had one last question, so number 2. So it says find the surface area of a right cone with a base radius of 3 and a height of 4. So this is kind of the same idea because we have our radius is 3 and we have the height. So height, remember, goes straight up and down to the center of the base. So we would still need to find the slant height. Do you guys know right away what the slant height is now? 5. Oh, you're now allowed to pass geometry because you guys know 3, 4, 5 right triangles. Right? Do we all know 3, 4, 5 now? Yes. All right, so we have a 5 there. So our surface area then would be that pi r squared plus pi r L. So it's going to be pi times 3 squared plus pi times 3 times L was 5. So it looks like we have 9 pi plus 15 pi. So we're going to get a total of 24 pi. And that was in inches, so inches squared. Okay, does this all make sense? Do you guys get it? You are now officially done with all your geometry notes. So exciting, isn't it?